Hey everyone, welcome to Two Car Pros. My name is Ryan, and today we are continuing our series on how to rebuild a small block Chevy. Our Chevy in question today is a Chevrolet 350. However, due to popular demand and a poll I put right here on the channel, so it's important you're subscribed so you can vote in these polls, they do matter, and I do what they say, is we're going to be stroking it out to a 383 stroker. So you can turn a Chevrolet 350 into a 383 stroker, effectively giving you more engine in the same package. But if you want to follow along and make a 350, you can totally do that too. It can go either way. Before we go any further, let's thank our amazing sponsor, Summit Racing. Summit Racing has been with us for years now. I think this is our 5th engine series we have built with them. They're an incredible sponsor. They have amazing selection, fantastic customer support, and easy returns if you don't get something quite right on the first try. So make sure you buy all your speed parts from summitracing.com. And what we're doing today is taking the crankshaft, pistons, and camshaft out in the oil pan, oil pump, things like that. Effectively, we are bottom ending the engine. Sometimes you might hear that phrase be thrown around. Basically, we're taking the bottom end out of the engine and prepping it to take it to the machine shop. Now, something in this video happens that's basically a showstopper, and you have to roll with those punches, and I'll show you exactly how to deal with that. With all that out of the way, let's jump in. So what I'm going to do next is drain our oil. Technically, you should do this before you even remove the engine from the vehicle, but sometimes you don't have that luxury, and you could even do it as the very first thing on the stand, but you technically don't need to. You can take the oil out at any point. You just risk making a mess. But what I've done is just clean this container because I'm really curious to see what the oil looks like. Mine happens to be a 5/8 bolt that is like really mangled. I don't think I'm going to reuse this, but go ahead and drain our oil. We should see something spectacular considering the condition of the engine. Water, 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 water. More water. There's some oil. Ooh, that was a big one. Wow, that's awesome. So go ahead and let that all drain out. You know, water or oil, and then put the bolt back when it's done draining. Ooh, ooh, ew! Once it's done or near done dripping, I'm just gonna put this back. You're never gonna get every single drop out of it. You're gonna make a mess. We're just trying to minimize that mess. And honestly, I don't think I'll be reusing this pan, although you totally could. There's nothing wrong with it. They're a non-wear item, but I'm probably gonna get a more high-performance pan in the future. So the next thing I'm going to remove is the timing cover, and this is a non-wear item. You could totally reuse this if yours is in good shape. However, ours really doesn't look that great, and a fresh build would be really nice to have a fresh timing cover since that's like a beauty part. This could probably be cleaned and reused, so maybe. We'll see if we get hot tanks up. Use a 3/8 socket and remove all these bolts. And hold on to these bolts as well. So our timing pointer is not a part of our timing cover. So go ahead and hold on to this. It's another non-wear item. Totally could reuse this. With all our bolts removed, our timing cover should just come off. It might require a little bit of persuasion because that has little dowels right here and right there. So those kind of need to be like walked off, and usually they're held on with some sort of sealant or adhesive. You just don't want to bend it so far that it is unusable. There we go. So we can see how used this engine is by how sloppy the timing chain is. It should be way tighter than this. This is like really close to jumping a tooth. In fact, it might have already done that. It's very possible. It's a nice unit though. It's a double roller. Yeah. This was nice when it was new, but this is totally unreusable in our situation. It is not in a reusable condition, so it's just gonna go right in the trash. So let's go ahead and get that timing set out of there. We're just gonna use a 1/2-inch socket and buzz these bolts off. You can reuse these bolts if you want to. They're not torque to yield or anything like that. There we go. Now this timing set is not reusable, so we're just gonna pull it off of our camshaft, take it off our crank, and toss it right into the trash. What I'm going to do next is put our bolts back, at least a few threads on the front of our camshaft, because I'm going to use these to turn the camshaft over. Sometimes the camshaft is so overheated it's actually stuck in the block, so I want to make sure that's not our problem. No, this seems okay. It turns over nice and easy. That's going to make getting the lifters out in the future a lot easier on us. What I'm gonna do next is invert the engine, and hopefully those lifters fall out, and then I also have this nice pan underneath my engine because oil is gonna go everywhere, and probably some water too, so watch out for that. Well, there goes one lifter. There we go. Have it completely upside down, and now we can take the oil pan off. So to remove our oil pan, let's go ahead and take off the 1/2-inch fasteners on the corners of the pan. There's a bolt there, and one there, and then there's a nut here, and a nut over here. And save these fasteners, they are reusable. And then we can remove all of the bolts on the sides of the pan, and those are 3/8. So this pan comes with a reinforcement rail, but I think that can just come with the pan itself. Go ahead and massage it around a little bit because they usually use sealer on these things, especially in the corners. It's not terribly uncommon for them to be really sticky. And then be careful too, sometimes the pickup can like interact with the pan, like a little hangover, and you don't want to damage that in case it's reusable. Just be gentle and move it up and out. Now, this is a really exciting moment because we get to see if it's a 2-bolt main or a 4-bolt main. I'm really hoping for that 4-bolt main. It's a 4-bolt main! Woo! No way! That is extra good news. What I mean by a 4-bolt main is right here. You see how there's 4 bolts holding the crankshaft to the block itself? That means that this block is set up for more power, it's more stable, it doesn't have as many shearing forces, the mains don't want to kind of rock back and forth. That is really good news. I know there's just 2 in the front, 2 bolt in the front, but the middle has the 4 bolts. That was excellent. Yes! So after taking the oil pan off, I noticed just this piece of metal. Well, that shouldn't be there, should it? Look at that. Ooh, that's a good piece. Oh, I like that. If you don't recognize this, this is a bearing. It's either on the rod or the main cap. I'm assuming it's a rod because it kind of looks small, but look how squedged out and ruined that is. Yeah, I'm not so sure this crankshaft is going to be able to be reused and reground, but you never know. And if we're doing a stroker kit, you can't reuse it anyway. But yeah, I just thought that was interesting. This little piece of metal was just kind of hanging out. I mean, actually, that's a big piece of metal if you're talking about inside of an engine, but still interesting. Next thing I'm going to do is remove the windage tray, just some 9/16 nuts. And then back here where you can't quite see, it's on this side of the pickup, is a 5/8 bolt. Pretty long bolt. And put that aside. We can totally reuse this. Then we can remove our windage tray. Again, this is a non-wear item. We can totally reuse it if we want to, but I think I might get a bigger windage tray when we put everything back together. So now let's remove the oil pump and pickup. I'm just going to remove it as one unit. Technically, you can reuse this, but in my opinion, it is better to get a new one and a new pickup. We don't know what's inside of this pickup, and I don't want it ruining my new engine. So go ahead and remove that. The drive will come with it. You can reuse the drive, the little drive shaft, but I'm not going to. I'm just going to get a whole new unit, and these are not very expensive, and it's a real bummer when they don't work. So just go ahead and toss this. I would get a new one. Now before we go any further, let's examine our situation. So we have a 4-bolt main, super, super cool, but you'll notice that we have 5 main caps. This one, this one, this one, this one, and this one. Now the first cap, pretty distinct looking. 5th cap, pretty distinct looking. It's going to be impossible to put this one on wrong, and this one, because it has an arrow. If it doesn't have an arrow, like all mine have arrows, go ahead and grab a punch or an engraver, something like that. They can put that arrow in there. Luckily I have the arrow, but you know what I noticed it doesn't have? Is numbers. You might be able to see a little bit of casting numbers right here. Those don't actually denotate anything as far as I can tell. Like they both have 3 in the first, number. I don't like that. So what I'm going to do is just grab a punch and just punch it right into the cap. So I know that this is number 2 and it faces this way because you can't mix this up. It might be a little hard to see on camera, but I can see a 2 right there, so that's great. So go ahead and do that for 2, 3, and 4, so when we put it back together, we can't mix any of these up. You can't do it. The engine will destroy itself. So the rods are a little bit different. Like, you could take this rod and put it over here or over there. It doesn't really matter when you're rebuilding the engine. The only thing that matters is, for instance, this cap and this rod have to go together exactly the way it came apart. They're basically a married pair. You can't mix them up, you can't have it turned around, and the orientation has to be correct. So what I like to do is take a V punch and then have it face the front of the engine. So that way, I know you can't really see it on camera, but it's pointing that way now. So that way I know the orientation, and my rods are already numbered. Like, this one says 96 on it, and so does the rod. I know you can't see that, but I can. So I know that these pair will always be together if you're going to reuse them. And yes, I know when they balance rods, they tend to grind on this surface, and that's why it's nice and smooth right here. But just, kind of tell them to keep the arrows on there for you, and they'll replace those arrows for you so you can't mix that up. If you're really paranoid, you can even just do it from the side. I know you can't tell, but there is a little arrow facing that way now, so I know how to put these back together. Rods are typically a non-wear item unless they are bent or cracked somewhere, but I think I'm probably going to get new rods anyway. That seems to be a thing I like to do on builds, and they're not terribly expensive, and I'd rather replace rods that I don't know are good with rods that I do know are good. The next thing I'm going to do is remove our oil filter, and truthfully, you could have done this at any time, but why not do it now? You're going to break it loose with some channel locks. You can probably even just use your hands. And it is probably going to dribble. That's okay. Ooh, milkshakey. Very nice. So the next thing I'm going to remove is this adapter. What this does is adapt the old style block to the new style oil filters, like the one we took off. It does have a pressure valve in it, so it technically is a wear part, and this engine has had metal strewn throughout it. I would not reuse this. They're not very expensive, and I would just go ahead and get a freshie. I'd hold onto the bolts, though, and those are a 7/16 head. I'll just remove that and toss it into the trash. The next thing we're going to do is focus on taking the pistons out. In order to do that, I need to be able to rotate the crankshaft over fairly easily. And how you accomplish that is basically take a 7/16 by 20 bolt. You're going to need at least 2 of them. I like 3, so it gives me options. And thread it into the back of the crank. And make sure you got a pretty good amount of threads on there, so you don't just snap the bolt off. I just happen to have these bolts laying around. But if you don't, I'll put a link down below in the description. You can even just use the bolts that came out of this for the flex plate. I don't have that luxury because those bolts are actually in the engine that replaced this one in the car that it went into. So we're just gonna have to use the ones we have, the ones we found, and it'll be good. There we go, and I'll show you exactly why we did that. So now to accomplish rotating this over, I'm going to use a very large prying implement. Maybe you can get away with a gargantuan screwdriver or something like this, but I really like a bespoke pry bar. And I'll leave a link down below in the description to one. And basically you put it between 2 of those bolts. We put it in the back of the crank earlier, and that will let us rotate the engine over freely because you have a ton of leverage. And what I'm going to do is I'm just going to rotate the engine up and over until cylinder 1 is at the very top of its travel, just because that's the way I like doing it. You can remove pistons whatever order you like. I'm just going to start with number 1. I already took the middle ones out. The keen observer will notice, but these are the ones I'm going to show. So just make sure that this is at the top of its travel and we can move on. So this is our number 1 connecting rod, and I want to show you something. There's what we call rod knock. So if you hear this sound, your engine is toast. So that is probably one of many problems that this engine had, because that is, that's really bad. So what we're going to do is take a 9/16 socket, and I'm going to use a nice long breaker bar to break these nuts loose on this rod. It's usually on pretty good. There we go. And I try to do these as evenly as I can, although I'm not going to be reusing these rods. But something to note if you are going to be reusing them. So we're just going to take them off a little bit. So I'm just going to leave it so there's just a couple threads hanging on, and I'll show you why that is. So now I have a close-up zoom of our number 1 connecting rod, and what I'm going to do is take a long, strong implement and put it on the back side of the piston, and I'm just going to give it a couple of taps, and you'll see it separate. Just like that, we see a nice little gap just right there, and we can continue removing the cap. Now, before you take any of the rods off, let's go ahead and talk about numbering them. So, if you are going to reuse your connecting rods, which in most cases you can totally do, make sure you number them number 1 and the orientation that it's facing, and then this one would be number 2 and the orientation that it's facing, and so on and so forth. I'm not going to do that because I'm not going to be reusing these rods, but it is a tech tip I thought I would give you because you don't want to mix them up, and at least the orientation. So we'll remove those nuts. So now we can put our implement back where we had it and then give it a couple more taps until the cap is kind of loose. I don't like to go all the way down because I want to treat it as if I'm going to be reusing everything, even though I don't think I'm going to be reusing any of this, but this is for your edification. And we can remove our cap. Well, a little sticky on that one. And you might notice something missing. There is no bearing. Yeah, there is no bearing on this rod cap. So that was probably the little piece of bearing that we found shot into the oil pan. That is truly remarkable, but yeah, we can just push the piston off of the crank and set our cap aside. So I'm going to take my long flat implement and put on the back of the piston once again, and normally you don't have to rotate the engine over like this. I'm just doing this for instructional purposes, and just give it some taps while you are supporting the connecting rod because you don't want that to gall the surface on your crankshaft, even though I think mine in particular is done for. Just give it some taps. And then as you're coming down, make sure your implement doesn't get caught in between the weights and the rod or the piston. Just keep giving it some taps until it starts coming out the top, which it's very, very close. So get ready to catch it. Like that. And then as it's coming out, we want to support the connecting rod with our hands so it doesn't gall the side of the cylinder too badly. And there we go, that's how you get a piston out. So go ahead and do that for the other 8 pistons. And don't worry, I'm going to show you the disaster one full of rust right now. So I said I'd show you number 7, and this is the one that was just covered in mud from before. So let's see how easy this one comes out. Might fight us a little bit. Oh, wow, that is stuck. A little more. Almost there. Oh yeah, look at how bad this one is. Woo-wee! That is a non-reusable, and look how hard it is to rotate the wrist pin. This can also cause light engine knocking right here. So the next thing we're going to do is remove our main caps. Now, if you had some hotshot race engine, you should go in sequence, but old American piece of cast iron like this, not too worried about that. We're going to take a 5/8 deep well socket and just break these bolts loose. They're usually on pretty good, so maybe a breaker bar. There we go. And we can just spin those out of here. Now, the cool thing about old American stuff like this is these are not torque to yield. These are reusable, so hold on to them. So we can remove these bolts. We can actually use these bolts to kind of shimmy the cap side to side and remove it from the saddle, just like that, and set that aside. And do remember that I marked these earlier, so make sure all of your main caps are marked. This one says 3 on it and has an arrow denotating which way it faces inside of the engine. Wow, look at this. That's part of the bearing and very sharp, so if you're handling something like this, just make sure that you are careful because that bearing is going to be an oil-coated razor blade. Look at that. Ooh, that's what we call genuine destruction. So this is obviously no good. Throw this into the trash. So go ahead and do what I've just done to the other main caps. So this engine has a one-piece rear main seal, which is super cool. It's held on with a 7/16 nut right here and some Torxes, which is an interesting choice for a fastener. And the Torx is a T30 Torx. Honestly, I really should have taken this off before I put it on the engine stand, but oh well. So go ahead and remove all the Torxes. I'm sorry you cannot see the ones that I removed previously. There's 4 fasteners total. I'm not sure why they use these Torxes, and this one is particularly long, so keep that in mind for reassembly. So go ahead and remove our rear main seal. Might fight you a little bit. Just come all the way back with it with the housing and take it out of here. Now this piece, the metal bit, is reusable, so hold on to it, but the actual seal itself, this rubber piece, is not reusable, and we'll show you how to punch that out and put a new one in when it's time for reassembly. So before I remove this crankshaft, I want to show something that is pretty unique and interesting. Right here, you can see that this bearing didn't come with our main cap, so all the other bearings are in the saddles and all the other ones are in the cap, so we removed, except for this one. This means the bearing actually spun in the main cap, which is pretty rare. You have to have pretty catastrophic engine damage for that to occur, but it still should be very easy to move our crankshaft by lifting it straight up and out, and these are pretty darn heavy. So brace yourself, make sure you don't fall over or anything like that. Up and out! So now we can remove all of our mains bearings that are still in the block side, and you just push down on one side of it, usually the side without the tang, so it kind of pops up. Or sometimes you can kind of rotate it like that, and then it'll just come right out for you, and go ahead and do that for all of our mains. So the keen observer will notice that I have not removed any lifters yet, and that's because they're pretty sticky in their homes, but what I can do is rotate the camshaft over completely. This would have pushed any of the lifters up and out of the way anyway, and then I can just fetch them after my cam has been retrieved. So what I can do is just kind of motion the camshaft forward and out the front of the engine. Now it won't go through. If the cam is in disagreement with the bore of its home, then it won't come out. Like if you're trying to wrench on it left and right, it's gonna get stuck. It'll feel stuck. So just try to be ginger with it. And if it's not going, give it a little jiggle, a little reorientation until it just comes out the front of the engine. And then when we get towards the end here, just gingerly take this, and in my instance, this is going directly into the trash. So now we're back on the top side of the engine in the lifter valley, and we're going to take our lifters out. Now, what I like to do in this situation, especially with like an unknown engine, I don't know if all these lifters have been rounded out, and they might be a little mushroomed on the part that actually interacts with the camshaft, especially in a destruction type situation like this one is. So what I do is just push them from the top side down until they fall all the way out and hit the ground, because I'm not going to reuse these lifters anyway, and if you're getting a new camshaft, you need new lifters too. And I never use like a sharp implement like a screwdriver to hammer this through. If this was really stuck, I would use probably like a really blunt implement to tap it through, because you can't gall the sides of the lifter bore, because if you gall that and there's a tolerance, if there's a scratch or something in there, you've effectively ruined the engine block. So it's really important to be gentle with your lifters and just push them out just like that. So go ahead and do that for all 16 of those. So I've taken all the bearings out of my engine. What you're looking at now is the second main cap on the block side, and you can see these striations in here. If you have these striations, don't do this because this can be razor sharp, but I can actually catch my fingernail on it. So this is like a super deep groove. You can even see it in the side of the saddle here on both sides. So what has happened is the bearing has spun inside of the engine while it was running and has created these really deep grooves. So, in my opinion, there's only one way to fix that problem. There we go. So effectively, what I've done is replace the block. Now, there's a lot of people out there that are going to be telling me, no way, man, you can weld that one up, grind it down, make it good. Between you and me, it'll never be as good as the original casting from General Motors, and you're going to spend way more money trying to fix the old block than it is to just buy these. These are a dime a dozen. They're everywhere. Just go on Facebook Marketplace or Craigslist. I promise you'll find a small block Chevy block. Now, the only difference between our old block and our new block is this one is a 2-piece rear main seal, and our first one's a 1-piece rear main seal. That is the only difference. They are both 4-bolt mains, and both small block Chevys. So you can still follow along. Just take that difference in mind when I talked about a one-piece rear main to begin with when I disassembled it, because I'll be putting a two-piece back together. So before we load up and go to the machine shop, there's a lot of material here to cover, so I'm going to do my best to be concise and memorable. So let's start with our crankshaft. This is what is actually going to make our engine from a 350 into a 383 stroker. This gives the piston more stroke inside of the bore. It comes down more. You're increasing the volume of the engine. More air, more gas, more power is essentially what the thought process is behind that. Alternatively, if you do not want to do a stroker engine, totally cool. Just use a regular crankshaft and you will have a normal sweet 350 and everything will be just fine there. And this is a cast crankshaft. You could upgrade to a forged one if you really want to, but these cast crankshafts are pretty darn beefy, and if you're not going forced induction, it's a solid route to go, and you save a ton of cash. The link for this crankshaft is linked down below in the description. To balance your crankshaft, you are going to need to bring the bearings. I have these. These are manufactured by ACL. They're under a Summit branding because we are sponsored by Summit Racing, and the link is down below in the description. It's a tri-metal bearing. I always go with a tri-metal bearing. These are going to be amazing, but they do need these to balance the crankshaft and the whole rotating assembly. Speaking of bearings, I have the other side of the equation for bearings, which is the rod bearings. These are also made by ACL, and they're that tri-metal blend that is really, really trick, and I always recommend these. And again, it is sold under a Summit part number, so it's effectively a Summit brand. You get a really amazing bearing for an excellent price with Summit Racing, and the link is down below in the description. Now, to fasten our main caps to our engine are these studs. These are made by Summit Racing right here in the US of A, and they are very similar looking to an ARP unit, but they are very cost effective, and these are going to be studs that hold the main caps to the engine, which prevents cap walk and essentially means you can make more power more reliably with these nice studs, and they have an incredible strength rating. I really recommend you going this route, and again, link down below in the description. Right over here is our engine damper. This is an externally balanced damper. This is just the GM performance unit. There is our part number linked down below in the description. This is the only unit I could find that I was really comfortable using that was externally balanced. So we'll move on to our connecting rods. This is an H rod. You can see it kind of forms an H because it has this raised lip, and the reason that is it's a much beefier, stronger connecting rod that can handle more power, and this is a forged unit. It has nice upgraded ARP 12-pointed fasteners on this side, so you get more clamping force onto the crankshaft. This is a super premium unit, and I always recommend getting nice beefy connecting rods, and of course the link is down below in the description. And then our crowning jewel of the lower end of our engine are these amazing forged pistons. These are made by Summit Racing under their Summit Pro lineup, made right here in the US of A, and you'll notice they have a little bit of a dish to them, and what that is accomplishing is actually lowering our compression ratio just a teensy bit from flat, because all the compression ratio, I've mathed it all out, is going to be in our cylinder head. So our cylinder head will have a slightly smaller volume, and with a flat head, it was too much. So I want to back that down. Our compression ratio is going to be about 10.22, which is just right, if you ask me. That is in the perfect Goldilocks zone for a hot street engine, and I always select forged because forged is stronger, and this is what's actually handling the fire inside of your engine, so I always want to go with a nice premium unit, and of course the link is down below in the description. And if you're worried about finding out what your compression ratio is, another link down below in the description is to Summit Racing's compression ratio calculator, and you don't really want that to be higher than maybe 10.5 for a street engine. The higher your compression ratio, the higher octane fuel you're going to have to run if you want to go full throttle, which obviously you're going to want to do at some point. So I kind of keep it a little, just a touch below 10.5, just a kind of a good rule of thumb, and that's all preference. And I'm sure you'll tell me down below in the comments what your preferred compression ratio is and why. And of course, the link is located down below into these amazing forged pistons. I completely recommend something like this because, again, this is what is handling all of the power that's pushing into your engine. So don't skimp on your pistons. So everything left on my table is what you're going to need to bring to have everything balanced. You're always going to need to have your pistons and your rods balanced to each other to make sure they're neutrally balanced and everything's happy. I also would double check the crankshaft no matter what. You could get it from the top of line engine manufacturer. I would always get the crankshaft checked because every single crank I've ever gotten from any place, it doesn't matter, was a good idea to check on it. Some of them are right, some of them need a little bit of a couple grams here and there taken off so everything spins really nice and freely. It's definitely worth the money. It's not very expensive, and I promise you that is a worthwhile step. All right, now let's talk about transporting your engine. I'm in the back of my pickup truck. I have a nice piece of wood down to protect the truck and the block. I put the main caps back in and tighten them down, not to any specific number, And then I grabbed some cylinder head bolts that I got from disassembly, and I put them in the block, a fair amount of threads in, so it's not, just going to pull out. And then I've tightened my ratchet straps down, so that way this block can't go anywhere. Watch. Yeah, that is not going to go anywhere and is going to be very safe for transit. Now, let's talk about what you're going to say to the machinist. Now, this is what you say to the machine shop. So you're going to take all of your block and your rotating assembly to be balanced. You're going to walk in and say, I'd like this block remachined and basically made assemble ready. I'd like it 30 thousandths overboard if possible. They'll tell you if it needs to be more or less. Typically on a stock bore, which in this engine is 4 inches, you can get away with 30 thousandths. So that's what I've done here, and I think that's going to be just fine. You're also going to want to have it mag checked, and mag check basically is a process where they charge the block with a negative charge and they have positive charge powder that sticks to the block, and essentially it makes it so you can see cracks easier. This ensures that the block is sound on the metal side of it, because you don't want to put together a block that has a big crack in it somewhere. Then you want to get it hot tanked so it's nice and clean. All the debris and grease and everything is taken off of it. Then machine 30 thousandths overboard. Align honed, so that way the crankshaft is perfectly concentric inside of the block. You want to have the head surface decked to make sure that's perfectly flat, so when you put your brand new cylinder heads on it, you have perfect sealing. Have them put in new cam bearings. That is a big step too. Make sure they put new cam bearings in, because that can be a little bit of a trick as well. And if you don't want to deal with putting in freeze plugs and oil galley plugs and things like that, you can have them put that in too, and that saves you a little bit of a headache down the road. And then have them balance your rotating assembly like I mentioned earlier. Balancing your rotating assembly is completely essential. Some people think you can kind of get away with just doing pistons and rods, and you can kind of do that, but I always recommend, like I said earlier, to do the crankshaft as well. So I just bring the entire rotating assembly and hand it to them and say, here, balance this. Do this for me. In the machining process, if you're not doing cylinder heads, it should be right around maybe $1,100, something like that. I'm in the most expensive state possible for that, and for me, it's probably going to be around $1,000 to $1,100, something around those lines. If you're somewhere a little bit cheaper, it's probably going to be closer to like $600 to $800, and that just kind of varies. I can't account for every machine shop ever made, but that's kind of what you should expect to spend. If you're really concerned about it, get a ballpark estimate before you even go. Just call them and tell them what you want to do and just give them a number. And then in our case, if you're doing a 350, you don't need to have this. But in our case, since we're making a 383 stroker, the block has to be stroker clearance. There's a couple little spots inside of the block that need to be machined a little bit bigger for clearance, so the weights are going to be a little bit larger and the crank sweep is going to be a little bit larger. So there's some things that need to be machined out of the way, and I'll show those when we get it back from the machine shop. But again, if you're doing 350, you don't have to have them do that. As far as finding a good machinist, look to Google reviews. That's how I find machine shops whenever I'm in a new area like this one is right now. Just look at Google reviews. Do they have good Google reviews? Great. Call them up, see if, you guys can work out a deal and see if you're comfortable with them. Or maybe you know someone that's machined an engine before, talk to them. You'd be surprised how good word of mouth and Google reviews are and pointing you to a good machine shop. So that's how to bottom end your Chevy 350. I'm doing this series so you at home can take apart a Chevrolet 350 and put it back together and put it in your hot rod and start having fun. I'm making this series as simple as possible so it can reach as many people as possible. And I'm going to show you every single nut, bolt, technique, and torque spec along the way. I will not leave you hanging, and we're going to put this thing on the dyno eventually to see how much power we're going to have. So that way, if you want to just follow along, you'll have the exact same power I'm making. Thank you so very much for watching. Thank you Summit Racing for sponsoring this series. It would not be happening without them. If you want to help out the channel directly, you can click that membership button down below, but of course that is always optional, but I do very much appreciate it. If you want to help out in a free capacity, you can subscribe and like the video. That really helps out my channel. Thank you so much for watching again, and I'll see you next time.